So in this section, what we're going to be doing is we're going to be assembling everything we've learned about figuring out derivatives and graphs in order to sketch a graph based on some information. And so the big thing is I want you to think of what we're basically doing is we're just trying to solve some puzzles. So in order to follow along here, what you should have is you should have either the packet you got in class last week, or what you should have is on Blackboard there's a packet available. You'll want to print the first page because what we're going to use is we're going to use that packet to sketch some graphs. So the first thing here is to note we have a table here and it gives some information about a graph, and we can look at various aspects of it here. So here we know the domain's all real numbers. We know we don't have any vertical asymptotes. We've got ourselves an x-intercept, a y-intercept, and we happen to know what the first and second derivative look like, and also what to expect at the ends of this graph. And what we want to use is we want to use all of this information to put together a nice picture of the graph. And the first thing we're going to do is we're going to use the first derivative here to figure out where our critical numbers. So we want to remember that our first derivative is going to have critical numbers when the first derivative is either equal to 0 or does not exist. Well, this function looks pretty good, so it's not going to have any places where it does not exist, but we can certainly set it equal to 0 and start solving. So if we do this, let's see, we're going to get 0, factor out an x, we're left with 3, minus 4, and of course I forgot that x in there. So this means x equals 0, or x could also be equal to 4/3. So these are going to be our critical numbers. The next thing we want to do is we want to figure out our possible points of inflection. So again, we take our second derivative this time, and we set it equal to 0. And we just get one choice now, x has to be 2/3. So we'll put 2/3 up in the box. So now that we've gotten the box full of information, we're going to use this information just like we did with first and second derivative before to set up some test intervals. So now what we need to do is we need to set up our intervals or x values that are going to be useful for when analyzing this function. And basically what we're going to do is we're going to use the critical numbers and the point of inflection to set up where we want to test, as well as the domain. So what our domain tells us is we want to start by looking at the value from negative infinity, and then we're going to go all the way up to our first number here that matters, either critical number or point of inflection, which happens to be 0. That means 0 is also going to be a special value, and then again we start again. So next we're going to go 0 to our next important value, which happened to be 2/3. So we're going to have another interval from 0 to 2/3. 2/3 will be a special value. We'll go from 2/3 all the way up to 4/3. 4/3 will be another special value, and finally we can look at our function from 4/3 all the way up to infinity. Next, after we've established our intervals, it's just like we did before back when we looked at the derivative and second derivative. What we need to do is we need to substitute these in now and see what happens. So what we can do is we can look here, negative infinity to 0, and pick our favorite test point. So let's test the value -1. And so first thing we'll do is we'll test it in our derivative, right, where we don't know what our function is, but we can test it in the derivative. And we turn the crank, we do the arithmetic, and we get 7. And the big important thing is that this means this is a positive value. Next, we can test -1 in our second derivative. We do all the arithmetic and we get -10, which is good because it tells us it's negative. And now we want to remember, what does this tell us about our graph? Well, the positive value here will tell us that our function is increasing. And of course, the negative second derivative tells us that we're concave down. So next we pick our next test value and we go down the line. We test 0. We can actually put these into our functions and see what happens. If we test 0 in our derivative, we get 0, which isn't terribly surprising, I guess. And if we test it in our second derivative, well, we get -4, so we still get a negative value. Next, we pick our favorite number that happens between 0 and 2/3. I'm going to go with 1/3 as my favorite value. We test it in the first derivative, and if we turn the crank on the arithmetic there, I believe we get -1, which tells us our derivative is negative. We can also test it in our second derivative. Oops, sorry, a little mistake there. I of course want to test 1/3. And if I put 1/3 into my second derivative, I get -4. So I still have a negative second derivative. Well, what does this tell us? Well, if we look here, we were increasing, 0, decreasing, right? So increasing, no slope, decreasing. Well, this tells me, of course, that we had a critical point here, and it happens to be a relative max, because we were increasing, then decreasing, and I'm also decreasing afterwards, and I'm still concave down, so I can even put concave down the entire time. This also seems to indicate I have a relative max, right? If I look at my graph, if my graph is always concave down and it has a 0 there, that's a relative max. So I'm going to go ahead and quickly fill in the rest of the table, but the important thing we should note is down here we should always show a little bit of our work. Show what we've tested, show what we've done, so that we can fill out our table. And so you should verify this is all correct, but the next step after we finish this table is now we're going to go ahead and use this to complete our graph. So the last step in this process is to take all this information and make a graph out of it. And so what we want to do is we want to recall a couple other pieces of information from the table. They're in your handout. But we had 2 intercepts, we had 2 limits as we approached infinity and negative infinity. And all of this is going to help us complete the graph. So the first thing I like to do is usually label the intercepts and label my axes. So let's go ahead and call this 1, 2, 3, -1, -2, 3. And then I'm going to leave myself a little more space here as we go vertically. I'm going to space those out a little bit more. So let's see, -1's there, which means -2 is here. And so what we're going to do is we want to record my intercepts on my graph. So what I'll go ahead and do is I'll record at -1, 0, I need a point on my graph. And also at 0, 3, I need to be a point on my graph. So those are my intercepts labeled. And so I can write on here, x-intercept and y-intercept. So the next thing to record is my end behavior, and of course fix my terrible typo. These are of course as x approaches infinity and negative infinity. So I can use this first one to say that, well, basically as I move to the right, I need to make sure my graph ends pointing up in that direction. And as I move to the left, I need to go down, so my graph needs to end going that direction. But now I can go ahead and fill in all the interesting ideas from the table. So what I usually like to do first is I like to record sort of what to expect and sketch an outline for what I should expect for increase and decrease in my slope. And I record that information along the bottom of the graph. So first, from negative infinity up to 0, I need to be increasing. So what I'll do is down on the bottom of the graph, I'll just make a little bar right here from negative infinity to 0 and write that I need to be increasing. Then I see from my table that I need to be decreasing all the way from 0 to 2/3 and from 2/3 all the way up to this is a terribly written 4/3. So that means I need to be from 0 all the way up until, well, 4/3 is about there. I'll be decreasing, and then for the final stretch from 4/3 to infinity I'm increasing again. So I just record a little guide that I'm going to be increasing again there. And now what I can also do is I can record my concavity information. So I see I need to be concave down all the way from negative infinity up to 2/3, and I'll record this above my graph. So from negative infinity all the way up to, well, 2/3 is about there, concave down, and then I'll switch over to concave up for the rest of the interval. So concave up. And of course I'm going to need to remember my point of inflection here, and I'm going to have to record that I have a maximum and a relative minimum here eventually. But this sort of gives me enough information that I can start sketching in what my graph should look like now. So what I know is over in this region I need to be both concave down and increasing. So sketch of my graph, let's see, and I need to hit these 2 points, so I need to go something like this. That's nice and concave down and increasing the whole time. So my graph is continually going up. It's kind of got this downward bowl shape. And what I'll keep doing is I'll continue this downward bowl shape, but I need to switch to decreasing. So I'll switch over here to decreasing until right here I switch inflections, or I have an inflection point, so I switch from concave down because I need to now follow the idea of concave up, but still decreasing until I get to here, at which point it looks like I need to have a minimum, and then I'll soup back up again. So I'll sort of, fix my graph a little bit here to make it sort of a better concave up shape. And so I can go back and I can look and I can see, well, does this seem to work, right? I got this kind of concave down bowl shape. I switched to concave up, so my concavity looks pretty good. I'm increasing until here's my max. I'm decreasing. Here's my min and 0. And of course, this is just an estimate. I don't know how far down my graph really went. But here I've got a relative min at x is equal to 4/3. I've got a rel max at x equals 3. And I've got my intercept labels. Now, I guess the one thing I should know is I wasn't told that this was an intercept, so apparently I should actually erase that a little bit and move it up. But for this part, we won't worry too much about it, okay? So maybe my graph shouldn't really dip down that low, but I think we're going to call it okay for now. It's got all the basic features. So again, if you have any questions about this, please let me know, but we're going to do several more of these in class. But the first step is to build the table, and then to use the table to translate it into a graph and make sure we label certain features. Alright, so make sure you take the quiz on Blackboard, and I'll see you in class. Bye.